Okay, we want to talk a little bit about compound interest. Now what we're really talking about here is when interest is compounded annually, and we're going to see what that means. Now hopefully you already know what that means. Any reasonable curriculum would have introduced you to compound interest in middle school. Okay, so compound interest, we consider if you have $1,000 and you get annual interest 10%. What do you have after a year if you have $1,000 at annual interest 10%? I'm blocking the board so you can think about that a minute. Well, now I'm going to tell you. Okay, well 10% is 0.1, isn't it? Because what does percent mean? It means per 100, and if that hasn't been drilled into you, it should have been. Okay, per 100, that's a very simple meaning. So 10% means 10 per 100. 10 per 100 means 10 divided by 100, that's 0.1. And to get the interest on $1,000 at 10%, we multiply 0.1 times $1,000 and we get $100. So I have a little table here. Our year 1, year 2, year 3, up through year end, but we don't know what to do with year end until we look over here. Okay? The old principal in year 1 would be the principal at the beginning of the year. We might have said beginning principal and final principal. Okay? But old principal, new principal. Okay? $1,000. Well, multiply that by 0.1, you get $100. And of course you have an intuition about 10%, I hope, and can do that without having to worry about multiplying by 0.1. Just take 1/10 of it. Move the decimal over 1. That's why I chose this. But understand that however you're doing it, you're actually multiplying your principal by 0.1. So $1,000 plus the $100 interest gives you your new principal, $1,100. You get to keep your $1,000 and you get to add 100 and you have 1,100. Okay? In year 2, then, if you're compounding the interest, you get to take 10% of the 1,100. Now if you weren't compounding it, if it was simple interest, you just get another $100 every year because you base it on your original principal. But in compounding, which is the only sensible way to do things financially, is you take your old principal, not because, well, you take your new principal from the previous year, and now that's your principal, and you take 10% of that principal to get your new interest. So you get more interest in a second. You get $10 more interest. Go have a party. Okay, and you end up then with $1,210. You can add these very easily. And then $1,210 is your old principal. You add 10% of that, which is $121. You get $1,310. Next time, you're going to get $131. And you know what I did? I get 13. Yeah, I wrote down 1310 because I wasn't thinking at all. If I add $121, I get $1,311, don't I? And it's 1,331. And if you know how to, binomial theorem and stuff like that, it's pretty obvious how that occurs. If you don't know the binomial theorem, another thing that probably is getting left out of the curriculum, much to our disadvantage. Okay, so I made a bonehead error there, but it's $1,331. In the next year, our interest will be $133.10, won't it? And we're going to add that, and so forth. Now we can continue doing that, but it would be great if we had a way just to skip to year end. If I want to know how much I'm going to have after 25 years, I don't want to have to do this 25 times, although if I had no other way to do it and really needed to make the prediction, it wouldn't be that hard. But as you'll see, it becomes impractical to do this when we're splitting up the interest and splitting up the compounding, as we'll see later. Okay, so anyhow, we get down to the nth year, and we don't have a good way to do this except to do every year in between. Well, we can develop one. all we have to do is use a little simple algebra. Okay, so if P stands for our principal, then what we get, if this is a principal at the beginning of a year, then we take 10% of that principal and add it, and we get the principal at the end of the year. Okay? Now, what I've done here is just a little bit of very simple algebra 1. I've just factored out P from this expression, and I see that I have P times 1 plus 0.1, I'll say it right eventually, okay? And 1 plus 0.1 is 1.1. This tells me that adding 10% to my principal gives me 1.1 times the principal, or 110%. And of course, if I'm adding 10% to P, I get to keep P, which is 100%. So 100% plus the 10% should give me 110%. So that validates this operation, this expression. Well, now we can revise our table. In year 1, our new principal is going to be 1,000 times 1.1, which of course is $1,100. That's easy. And then the second year, it's going to be 1,000 times 1.1 multiplied by 1.1, which is just 1,000 times 1.1 squared. Well, 1.1 squared is 1.21. Now, little note here. One plus 0.1 multiplied by 1 plus 0.1 is 1 plus 0.1 plus 0.1 plus 0.01, which is 1.21. And you just use the distributive law to square this thing. And that's going to give us, of course, multiplying by 1,000, that's going to give us our 1,210. Well, in the third year, what we want to look at is we're multiplying 1.1 times our old interest, which is going to give us 1,000 times 1.1 squared times 1.1. Well, rearrange this, we've got a 1.1 cubed there, haven't we? And now the pattern is totally obvious, and we could get formal with mathematical induction, something I'd like to do, but I guess we're probably going to be rushed to do other things and maybe not be able to talk about that. That would be one of the enhancements of the Math 154 course that I would very much like to do. So I'll probably do a video on it for your option, but it won't be required. Okay, so anyhow, we get down to year n. Well, the power here is clearly going to match the year. It's a no-brainer if you think about it. And we see that we're going to have 1,000 times 1.1 to the n. Now that's going to come from, if you want to put the n minus 1 year here, because if the year is n, the year before was n minus 1. In the year n minus 1, it'd be 1,000 times 1.1 to the n minus 1, which we then multiply by 1.1 to get 1,000 times 1.1 to the n. Make sure you understand every detail of what I'm saying. Okay, so now in function notation, we can say that p of t, that's not p times t, that's p evaluated at time t, function notation. P of t is 1,000 times 1.1 to the t. It looks like I made a bad multiplication sign there. It looks like plus, so we better fix that. Okay, 1,000 times 1.1 to the t. Well, now what if our interest rate is not 10%? Because you're probably not going to find an interest rate of 10% in any safe investment in the current economic situation. What if the percent was 5%? Well, then 5% would be 5 per 100. 5 over 100 is 0.05, 0.05. And when we add that to 1, we get 1.05 here. So we'd have 1,000 times 1.05 raised to the t. Okay? So whatever the interest rate is, we're going to add that rate to 1 to get the number we raise to the t power. So if the rate is r, now by interest rate, okay, when I say the interest rate is 10%, the interest rate is not 10 numerically. Okay, the interest rate of 10% is 10 per 100. The interest rate is 0.1, as we see here. Okay, so if your interest rate is r, if you have 5% interest, r is 0.05. And your expression would be p of t is 100 times 1 plus 0.05 raised to the t. Whatever your interest rate is, it should be clear then that your principal is going to be $1,000 times 1 plus that rate raised to the t. Okay, this is interest compounded annually. Okay, well, I'll make the note over here because this is kind of a payoff here. This is an exponential function. It's b to the t with b equals 1 plus r. And there's actually a name for this. The base of the exponential function in this case is called your growth factor. Okay, so R is your growth rate. And a growth rate is not a rate of change. So you want to keep that in mind. A rate of change is a slope of a fundamental triangle. It's a change in one quantity divided by a change in another. The change in the rise quantity divided by the change in the run quantity. That's not what this is. That's not what a growth rate is. A growth rate is something you multiply by a quantity to see how much it changes. Okay? And that's very different. So don't confuse the terminologies. We've got the word rate in both of these terms, rate of change and growth rate, but the growth rate and rate of change are two completely different things. Now there's relationships between them, but they're different things. Okay, so that's compound interest when the interest is compounded annually. Now we can compound interest more frequently than annually. Typically interest is compounded quarterly or semi-annually or monthly or daily or continuously, which is a very interesting thing, and that's where the definition of E arises.